Okay, today we're going to evaluate the derivative of each of the following functions. The first one being y equals x squared plus 4x minus 3 all over x squared plus 4. And the second one being y equals x cubed minus 2 over x cubed all to the power of 9. Let's take a closer look at the question. Evaluate the derivative of each of the following functions. Derivative just means to differentiate. So let's start by differentiating the first question. Y equals x squared plus 4x minus 3 all over x squared plus 4. Note how we're dealing with a fraction, therefore use the quotient rule. The quotient rule from the log table states that dy dx equals v by du dx minus u by dv dx all over v squared. With the fraction, the top line is u and the bottom line is v. Let's deal with u first. U equals x squared plus 4x minus 3. Recall, to differentiate a function, we apply the following. If y equals x to the power of n, dy dx equals n by x to the power of n minus 1. Also, in differentiating a constant, which is just a number, the result is always 0. Let's apply the same rule here. If u equals x squared plus 4x minus 3, du dx equals 2x to the power of 2 minus 1 plus 4 by 1 by x to the power of 1 minus 1 minus 0, because each time we drop the power and decrease the power by 1. Therefore, du dx equals 2x plus 4. Moving on to v. v equals x squared plus 4. Therefore, dv dx equals 2x to the power of 2 minus 1 minus 0. Therefore, dv dx equals 2x. Now let's gather together all our ingredients. So v equals x squared plus 4, u equals x squared plus 4x minus 3, dv dx equals 2x, and du dx equals 2x plus 4. By subbing our ingredients into our formula, we get dy dx equals x squared plus 4 by 2x plus 4 minus x squared plus 4x minus 3 by 2x all over x squared plus 4 all to be squared. So we simply multiply the brackets, which will be dy dx equals x squared by 2x plus 4 plus 4 by 2x plus 4 minus 2x multiplied by x squared plus 4x minus 3 all over x squared plus 4 all to be squared. Always be careful with the signs when multiplying, and that will leave us with dy dx equals 2x cubed plus 4x squared plus 8x plus 16 minus 2x cubed minus 8x squared plus 6x all over x squared plus 4 all to be squared. So by adding and subtracting the like terms, we get dy dx equals minus 4x squared plus 14x plus 16 all over x squared plus 4 all to be squared. Thus if y equals x squared plus 4x minus 3 over x squared plus 4, dy dx equals minus 4x squared plus 14x plus 16 all over x squared plus 4 all to be squared. And that's sum done. Alright, so let's move on swiftly to the second question. Y equals x cubed minus 1 over x cubed all to the power of 9. Notice because there's a bracket and a power outside the bracket, we use the chain rule. So with this method, we get the derivative of the bracket as a whole, then multiplied by the derivative of what's inside the bracket. The chain rule from the log tables, they say if y equals u to the power of n, dy dx equals n by u to the power of n minus 1 multiplied by du dx. In this case, u is simply what's inside the bracket, so u equals x cubed minus 1 over x cubed. And let's recall from the log tables that 1 over a equals a to the power of minus 1. So similarly, we can say 1 over x cubed is equal to x to the power of minus 3. Therefore, u equals x cubed minus x to the power of minus 3. So if u equals x cubed minus x to the power of minus 3, du dx equals 3 by x to the power of 3 minus 1 minus 3 by x to the power of minus 3 minus 1. And don't forget that a minus by minus always gives a plus. So du dx equals 3x squared plus 3x to the power of minus 4. And notice we can take out 3 as a common factor, so du dx equals 3 all multiplied by x squared plus x to the power of minus 4. And let's recall our function now. Y equals x cubed minus 1 over x cubed to the power of 9. Therefore dy dx equals 9 multiplied by x cubed minus 1 over x cubed to the power of 8 multiplied by du dx. We worked out du dx to be 3 all multiplied by x squared plus x to the power of minus 4. Therefore dy dx equals 9 multiplied by x cubed minus 1 over x cubed to the power of 8 multiplied by 3 multiplied by x squared plus x to the power of minus 4, which can be written as dy dx equals 9 by 3 by x cubed minus 1 over x cubed to the power of 8 by x squared plus x to the power of minus 4, which can be simplified down to 27 multiplied by x cubed minus 1 over x cubed multiplied by x squared plus x to the power of minus 4. So y equals x cubed minus 1 over x cubed all to the power of 9. Therefore dy dx equals 27 multiplied by x cubed minus 1 over x cubed multiplied by x squared plus x to the power of minus 4. And now I'll end the video with some important notes to take when finding derivatives. Always write down the appropriate rule beside your work. Working out the answer can be a tedious process, so take great care to avoid silly mistakes.